So Sienna owns a coffee shop. A coffee machine was purchased for $12,000. So we've been calling this VO, remember, our initial value. So sometimes when I'm reading them, I like to put that in there just because it might help me. Now, it's saying it's depreciated, and it's going to tell you what type of depreciation. And here you go. It says the unit cost depreciation. So you know you're using your unit cost formulas. So you can go to that section of your formula sheet. And it's at a rate of 0.05, so 5 cents a coffee. So what they told you there, if you look at your depreciation, unit cost depreciation formulas, they told you the D value. That's the use. So it's 5 cents per use. And now they've created a recurrence relation from year to year for the coffee machine. So this is year to year. So within a year, it drops in $1,440, and that's because I can see that. Now, just to recap what we were talking about before the holidays, a recurrence relation is when they write this, when they write the VO, they're just using a different letter. It doesn't matter, MO, same thing. So if you're asked to write a recurrence relation, you have to show MO, which is what they've done. Then they write the rule of how you would get the next term, and that's what the N plus 1 means. So if you remember, Vn plus 1 means is the rule of how to get next term. Yeah? So just when you're doing it in a sequence format and you want to keep getting the next one. So I can see the rule here. If I was to get the value of this coffee machine in the next year, say in the year 1, I would take what it was in the beginning, which was 12,000, and I'd minus 1,440. All right, so it said calculate the number of coffee that the machine produces per year. So they said it was unit cost. So if you can see, we're saying that it drops by 1,440 is the drop per year, yeah? But they said it's unit cost. So that means it dropped by so many coffee cup uses. So what we're going to do is we know that one coffee costs them $0.505 or 5 cents. So if we do that, we can find out how many coffees this machine sold in the year. All right, so that ends up being 28,800. Now, think about it when you're doing finance. Really good to know if you've stuffed it up is just to think about reasonable answers. This is a coffee machine purchased for a coffee shop. Do you think 28,000 coffees in a year, that's pretty reasonable, yeah? That's going to be okay. So that's a good number. So we'll stick with that. So calculate the number of coffee. That would be my final answer there. Okay, the recurrence relation above could also represent the value of the coffee machine depreciating at a flat rate. So flat rate was when it's up here. It's actually written sort of in a flat rate form there. Okay, so if you look at it, the flat rate form means the same amount is taken off every year. And we can see that that's 1,440. So when it says what is the annual depreciation amount, if you go to your flat rate formulas, you'll see that the D has a formula of it's the rate over 100 times VO. Now we know what D is in this instant. We know that it's 14,400. And put too many O's there. And we know we're looking for the rate, which is that R there in the formula. And we also know what it originally cost, which was 12,000. Yeah. So here we can just use solve. Okay, comma R. So you don't need to write on your paper solve. But I'm just showing you that's what you would be doing in your calculator. And you end up with R equals 12%. So for a machine to depreciate about 12% per year, that sounds reasonable too. things like drop off. Machinery have a, can have a high depreciation rate. Yeah. So 12% sounds pretty good. Okay, so complete the rule below that gives the value of the coffee machine after n cups. So what they're talking about here is the nth formula, yeah? So if you remember the nth rule, we have formulas in our thing. So they're talking about flat rate, and you would go to the nth rule. And if you see that, if you went to your summary sheet, you could have a look at it. So flat rate, I'm just going to write it here. Flat rate, the nth rule says Vn equals Vo minus n times d. And you'll see that this is highlighted and this is highlighted. That means you need to write them out, or you need to substitute it in when you're doing that. So here you can see they've left the blanks. So they're using Mn instead of Vn. So the first number is going to have our VO. So what's VO in this instant? Yeah, good. So we just have to put in 12,000 into there. Now it says plus. Now, but my formula says minus because this is depreciation. But can you guys see in there? I know it's a little bit easier on my screen, but it does say plus in there, doesn't it? Yeah? So that means you need to be careful because it's depreciation. What does it need to be? So that means in here, so we've got the n times n. So that means this value is going to be the d. But I need to make sure the minus is written there because it's saying plus and I want it to be a minus. So I'll have to write minus. Now this is after, oh, sorry, this was actually unit cost. Yeah? Sorry, I should write unit cost. Because they said after n cups, so we want to use the unit cost. It's still the same formula where D is the cost per cup. Okay, so if we look at what was the cost per cup, like how much did it cost? Yeah, so we just have to put that in there, but we needed the negative. That was the trap. Okay, so this question 23, consider the following 4 recurrence relations. So they're recurrence relations because they've got VO and an n+1 rule, representing the value of an asset after n years. Asset just means an item, yeah? And then it has a few there. How many of these recurrence relations indicate the value of the asset is depreciating? So if it's depreciating, it means your value would keep getting smaller, yeah? Would that true? Everyone agree with that? Yeah? So if you look at this first one, does this formula here look like it would get smaller? No, because you're adding, aren't you? So is this one? No. This one is what would be growth, yeah? Okay, now the next one, it's subtracting there. So do we think that one would be decreasing? Yeah, so yes, we'll say yes, this one is a decreasing. Now, this one, the next one, is getting timesed, so I might just write here, times by a number less than 1. Does that mean depreciation? Yeah, that equals depreciation, doesn't it? So we'll just say that one is a yes. Now, the last one, we need to be a little bit careful. Here, this part, this first part here, when I talk about this indicates growth, doesn't it? If you times by something more than 1, it's going to grow. But this part is decay. But what you need to check is the growth going to be more than the decay? Yeah? Because if that is, it means it's growing. If the decay, the minusing, is more than the growth, then it's going to keep going smaller but at a slower rate, yeah? So what you can do is you could just do it recursively in your calculator. You know how when we press 20,000 and press enter, and then you could times it by 1.125 and minus 2,500, and you'll see it stays the same. So is this one decaying? No. So that's all you're getting asked. So we're going to say no, this one is not decaying. So how many of these were decaying? Or depreciating, sorry? 2. So there's our answer. Sally buys a machine for printing brochures. The machine is purchased for 17,000, so we got the VO there. And it says she prints 25,000 brochures a year. The value of the machine is depreciated using unit cost. So remember, I told you they're always going to tell you. So now you know you've got to go to unit cost formulas. And it says the machine reaches a scrap value. Scrap value is the word they use. Once an item is not brand new, it then has a scrap value, whatever its value is now, okay? So that's what it is. That's what that means. So it says the machine has a scrap value of 22,000 after 5 years. So what they actually gave you there in this bit, there, is what they actually gave you V5. So V5 equaled, or 5 years equaled 2,000. Well, I was going to say the value at 5 years. I shouldn't say V5 because it's actually unit cost. Okay, so the rule for the value in dollars of the machine after N brochures are printed is, so they want the nth rule. So if you go to find out, I'm going to check. So I've gone to the formula sheet. I found that it's unit cost and they want the nth rule formula, which is this one here. This is the nth rule. Okay, so to work out the nth rule, I need VO, which I have up there, is 17,000. So, and then it's minus N times D. Now, D's highlighted. That means I need to calculate what D is. And you can see D says the amount it depreciated in the period. So I normally say the drop in price. That helps me make it easier, over the amount of uses. That's what all that means. So if you think about the drop in price, it was 17,000 and it went to 2,000. And the amount of uses, well, it uses it for 25,000 each year, but we had 5 years, didn't we? So I'm going to do times 25, 5 years. So when you do that, you end up with 0.12. So what does that mean when it's 0.12? What's that telling me? What do we know about that? It's 12 cents, yeah? And what does that mean? It costs them 12 cents to make what? One brochure. So where's the rule for this one? What's the answer? Yeah, so we can see if we were writing out this rule, we would have the seventh VO, which is 17,000, and we've found D to be 12 cents, so it's that one. Okay. Okay, question 7. Samuel owns his printing machine. The printing machine depreciated in value by Samuel using a flat rate depreciation. So we know it's flat rate, and they give me a recurrence model there. So they said VO is 120,000, and then how I get the next term, or the value of the machine. Now this is after N years. It's important to do that. So every year the machine's dropping by 15,000. I can see that. So then that was the first question. So what amount does the machine drop? So you need to be able to read that off and say, all right, it's 15,000. Okay. Showing recursive calculations determine the value of the machine after 2 years. So we went over this. You must show, it's only 1 mark, but you must show all of this. So you have to show the value of the machine after 2 years. You've got VO, so you have to show that V1, it would have been 120,000 minus 15,000, which equals 105. Then you had to show that V2 would have been that value, 105, minus the 15,000. And then you got, which is, what's that, 90,000. Okay, so you had to show it like that. If you don't have that all written out, you're not getting your mark. And 1 mark in further is huge. You drop really quickly. Okay, so what is the annual flat rate percentage used by Samuel. So you're looking for R. R's the question there. So if you go to your flat rate formulas, okay, so I've got the flat rate formula and I've found it on my sheet and I've just dropped it here for us today. So we want the annual flat rate. So if you have a look, that R value is in that D formula. And we know what D is because D equals, what does it equal in this scenario? Yeah, 15,000. So what you could do is you could say, all right, 15,000 must have equaled the rate over 100 times VO, which I do know what VO is, which is 120,000. So I've used this formula and I'm just going to chuck in solve. And as I said, you don't need to write the solve on your paper. You can write that formula and all the substitution. Don't bother writing solve though. Okay, so we get R to be 12.5%. So this printing machine is dropping by 12.5%. Now, is this sounding reasonable? Yeah, because we've done a few things now and we've noticed machines are dropping about that rate. So that's good. Because you need to do it, because sometimes if you say the machine drops 2%, that's, you know, say it was 1.2 because you've done something wrong. With a 0 or whatever, that's going to be wrong. Or you got 120, you know, you got a bigger R, then that's wrong. You should be adjusting it, you know, realizing that. And that's how you check your mistakes here, and that's how it'll be better. So the value of the machine after n years. So here, this last question, we're sort of trying to get, they're talking about the nth term formula, which is here. So the nth term, so you're already like opening on your reference book, you're probably looking at this, and it says it could be determined using this rule. And you can see they've put the basic rule there. So they wrote it like that. On our formula sheet, it's written like, it's written like this. Oh, my pen's not working. So the nth rule is written like this. So you can see it says write down in that formula. That that's okay, but they want plus there. So we were going to have to just change that to there. So we're going to write VN. So this A value is our VO. So what was our VO in this scenario? Yeah, 120,000. And then we're going to say minus. Even though they say plus B, it's not plus B, it's minus. We're depreciating. So we're going to say minus. And how much was it minusing every year? So we write 15,000 N. Sorry, there. Okay, so there's our N. So this one, the graph shows the value of an asset that depreciates over a period of time. Okay, which of the following depreciation situations does this graph represent? So if you remember, we sort of briefly talked about that in general, I'm going to say in general, if you just were not changing a scenario, say you had the value over N, if you have flat rate depreciation, you would see a straight line. If you have, and the same with unit cost, yeah? Even if over so many years, it's a flat rate, it's going down by the same amount. So you might say that. We say a straight line and the same amount dropping. Okay, when you have, and we talked about it, when we, we'll go into it. When we have reducing balance depreciation, so we're about to head into this, but I'll show you. When you have reducing balance depreciation, it's going to be a curve line like that. So or growth or whatever. Sorry, I did the line the wrong way. It'll curve down like that. So when you first glance at this one does, if you sort of just like look like that, it looks like it's curving, doesn't it? But it's not actually. If you look at this first bit, if you see here, between these two, see there, it drops by the same amount. Between those 2 years or months, sorry, it drops by the same amount. So if we're dropping by the same amount, that means it's flat rate. That's flat rate or unit cost, whatever. And then you see, then you have this bit, it drops a big bit. And then you can see that can you see here, it drops by 4 and it's dropping by the same amount there, isn't it? It's every time it's dropping by 4 now. So this is still dropping by the same amount, but it's a bigger drop. So it's a bigger drop, which means increased rate. Okay, so it means it's going down by an increased rate. So if you go through these things, it says which of the following situation. So a flat rate depreciation, yeah, we think that, with a decrease in depreciation rate after 2 months. Did the rate decrease after 2 months? Decrease? Did it get less? Did it drop by less or drop by more? More. So the depreciation rate increased. So which answer was going to be? It's going to be B, because it's increasing there. Okay, the other one, you can see it has down here, you can see it's got these reducing balance, and that's because your first eyesight, it looks like it, and that's where they were trying to trap you. So kids went off and went, yep, it looks a curved line, I'm going to say it's reducing balance, which we're going to do in our next lessons. This number up here just says how many got it correct in the state. Correct in the state when it was done, whatever year this was done, so 39%. So I can tell you now, it was because it looks curved. So what do you want to do is you just want to check what's happening. If they're dropping by the same amount, it's flat rate. If there's a change in scenario, then you can see something's changed, but first check that before you go off and say that it's a curved line. Okay, so Barb drives a company car she bought for $50,000. So there's a VO. She depreciates the value of the car for 20 cents per kilometre it travels. So on the graph, you had to plot the 4 points. So what you're going to do is you can see up here they've done the 50,000. So they want you to plot the points of 20,000, 40,000, 60,000 and 80,000. So all you're doing is just going 50,000 minus, and the first one would be 20,000 times the 0.2 use. And what does that end up being? Okay, so I've calculated those 4 points and I've popped them on. They just said plot the points. You don't have to connect the lines. They just want you to draw those dots. So that's all you have to do. And then the next question, it says, complete the rule below that gives the value of the car in N dollars after N kilometres have been travelled. So that is your nth term formula or nth term rule. Okay, so if you go to, this is unit, so looking at our formula sheet, they want this formula over here. So we have to write VO goes in here. So what was it originally? 50,000. And how much? And then it's N times D. And you'll know D is the cost per use, which was what? 20 cents, wasn't it? Now, what else is, it's got a plus there again. So what do we need to put? A negative in there. So just be really careful. They seem to be doing that. And it's so that you're making a choice. Yeah? And you need to understand that it's depreciation. So if Barb travels 20,000 kilometres each year, the value of the car could be considered to be depreciating at a flat rate. Sorry, this is flat rate. What is the annual flat rate? So instead of saying it's use, well, if you know it's 20,000 Ks a year, so if I do 20,000 times the 20 cents that we get, you get that it drops by 4,000 per year. So that would be your D value. So D would equal 4,000 in the flat rate scenario. Okay? So you want to know, and the question is actually asking you for the annual flat rate. So that is actually your R value. So if you go and use your formula, I'm just going to do it over here, right over here. So D equals R over 100 times VO. You could go and work that out. You could say, all right, sorry. Okay, so you could go and write 4,000, that's D, equals R over 100 times the VO, which I know is 50,000. And you can just use your solve again, comma R, and we end up with a rate of 8% per annum. Is that pretty reasonable for a car? Yeah, no carbon, yeah, but 8% is okay. Okay, so Pina owns a workplace equipment which she depreciates using a flat rate depreciation. The value of the equipment after N years can be determined by this. So here they gave us the nth rule. Okay? It says determine the equipment after 1 year. So you pretty much just want V1. Just be careful, it was an N-year formula. So V1 would be 200,000 minus the 12500, which times 1, if you like, which ends up being 187,500. And then how many years will the equipment first have a value of 0? So you can use the nth term, and you could say, see this nth term formula, and you can say you want the value to be 0, and what you're trying to find is n. So you could do here the solve. Now they're just asking after how many years. So if you solve, it ends up, this one ends up being an exact, so n equals 16. Okay, so you can say after 16 years. That's fine. The value of the equipment in N dollars after N years can also be modelled by a recurrence relation. So now they want you to write the recurrence relation. So you know it's flat rate and you want the recurrence. So, okay, so you've gone to your formula sheet. This first column here is the recurrence relation. So a recurrence relation, you always have to write the VO, which is 200,000. And then you have to write the Vn plus 1 rule. And you can see up here, I write Vn minus, and I have to work out D. D's highlighted, that means I need to know. But how much does it depreciate? What does it want? In years? So how much is it dropping per year? You have to look up there. You can see it in your nth term formula. What's D? Yeah, 12,500. So there, you've written that out. Now, this one, I'm going to help you out with this one because we haven't actually covered reducing balance. So using Pina's depreciation model, the value of the equipment decreases by a fixed percentage of its original price. So this statement here, a fixed percentage of its original price, that is a way of describing flat rate. Okay? The next bit they say, alternative, the value of the equipment could be depreciated by a fixed percentage of its current value. What that means is it's the same percentage, but it's dropping off, say you had, it's dropping by 8% in the first year of the original value, then it drops by 8% of what the value is now. So that's called reducing balance depreciation, which we're about to do, but you can just write your answer in there, reducing balance depreciation. So that's when you're taking it off the percentage of the new total every year. Okay, so that's a way of saying that.